Welcome to today's session. In today's session, we will see how to build classification model using H2O AutoML feature. A quick recap of H2O. H2O is an open source machine learning platform. It is built on using Java programming language. AutoML feature, which is accessible using R or Python, using which we can build automatic training and tuning of many complex models with very less user input. A quick recap of classification. Classification is a supervised learning technique. Using the historical label data, model tries to predict a categorical value. So first we have to import all the libraries required for this tutorial. So first is the OS and H2O and AutoML package. So let me import it. So once that is done, then just you have to set the working directory. Using H2O.init, we will be instantiating the H2O AI instance in the local server. So once we run it, it will instantiate a local host server, H2O server in the local machine. Today, as part of this classification exercise, we would be using following data. It is a 500 row data which has information of 500 people, their gender, height in centimeter, weight in kilogram, BMI, body mass index, which on the scale of 0 to 5, 0 being extremely weak and 5 being extremely obese. We are trying to predict BMI index. BMI is not a continuous variable. This problem is a classification problem. So first we have to import the data file. So for that we will be using h2o.import file and give the file name. Once that is done, it will import the data, training data into our environment. So let's see the top few records using .head command. So it will print out the first few rows of the training set. So using the .describe function, we can understand the data type and summary of the data. So here the data has 493 rows and 4 columns. So out of the total 500 rows, I've kept aside 7 rows for testing and trained the model using the 493 rows data. Here, only the gender column is of categorical type. Height, weight, and index has been read as int. I think the height and weight is fine. The data interpretation of index is wrong. Index is actually a categorical value. It's not a continuous value. So we have to typecast it into a categorical value before executing the model. So other details are minimum, means, maximum, standard deviation, zeros, number of values which has 0 missing, and first few records. First thing which we have to do is convert the index to a categorical value. So that is done using this as.factor. So we will reassign, change training index column into categorical and reassign the data to the same column value. So once this is done, it will be changed to a categorical value. So if we don't do this, please note it. If we miss out this step, then AutoML will treat this problem as a regression problem and try to build a regression model. So take care of using the correct data type for the target value. AutoML uses the data type of the target variable to identify whether it is a regression model, whether it has to build a regression model or a classification model. So we have to be very careful. We should not miss out this particular conversion step. We have to specify y, that is the target variable, column name, and set it to y, and x would have the column name of all the independent variables. So here gender, height and weight are the independent variables. So once these two values are set, we have to call the AutoML function. So AutoML function accepts max model, number of models it has to build, what is the runtime it has to wait for, and seed. So we have to use these attributes judiciously, trying out with very large number of models that will take a hit on the performance, and model training time will be very huge. To AML.train, we have to just feed in X variable name and Y variable name and give the training set. So once we see 100% the model is built, now we have to put the leadership board. So leadership board is a snapshot of top performing models. So that can be printed using aml.leadership board, and lb.head will print out the top performing model. So it will print out the top 10 model because we have asked for only 10 models. So once that is done, it will print out the error metrics. All these values are error metrics. So lower the value, better the model. And the default metrics chosen is mean per class error. Following are the error metrics. I think for this example, it has not built AUC, but AUC also is important error metrics which is used in this AutoML. AUC is nothing but area under the curve. It measures the quality of model. So for any random classifier, area under the curve value is 0.5, and a perfect classifier that is with 100% accuracy will have 1 as AUC value. So all the classification model we built, it should be between 0.5 to 1. So anything lower than 0.5 will be discarded. So next is mean per class error. So it is the average of error rate for each class. The prediction gives out the probability of each class. We have 3 classes to predict: class A, class B, and class C. Let us say if out of 20 it has 1 wrong prediction, and class B it has 1 wrong prediction out of 50, and class C 2 wrong prediction out of 30. Then the error rate mean per class error is mean of 1 by 20, 1 by 50, and 2 by 30. That is 4.556%. Next matrix is loss error. The prediction is probability of for answer being each category. This confidence is used for calculating the loss. Next is mean square error. We have seen this also in the regression case, but here mean square error is with respect to the probability. So that is, let us say if we have 3 classes and model guesses for A with probability of 0.91, and B 0.07, and C 0.02. Then the error is for A is 0.09, B is 0.93, and C is 0.98. So next we'll see how this model prediction works. We have to read the test data. We'll use the h20.import file, give the file name. There's no difference of method signature for regression or classification. So the prediction output will give probability for each class. Since we had five levels in our target variable 0 to 5, so for each class it will try to give out the probability, and the class which has the maximum probability, that is treated as the final value. So here for the first row, for class 4, that is, it has the maximum probability, and that will be the predicted value. Same goes for each row. So totally, I think there are 7 rows in the test data, and for each it will try to predict the value. Let us see what is the actual result. So first row 4 is correct, then it has predicted 4, but actually is 5. Then 2 is correct, 3 is correct. Then 2, it has predicted 2 there, but it is actually 1, 5 and 3. So let's see how is the accuracy of the model using the accuracy metrics. If we give out the actual value and the predicted value, it will give out the accuracy score. Here I think it has made mistakes in 2 rows, so accuracy is 0.714. We've completed the tutorial for classification model. Thank you.